Okay guys, I'm going to go over the review. This is page 1 of the review. You must know the details regarding sunsets. Essentially, I made a video over this already, so what I'm going to tell you is that you need to make sure that you know that if you have a sun right here, alright, it's scattering that causes the sky to be blue, so that's the reason the sky is blue, alright, blue sky. It's scattering that causes clouds to be white, right? The reason we have white fluffy clouds is because of scattering. The sky, the atoms in the sky scatter the blue light, so we see blue. All the other light gets to us, which is why we see the sun is yellow. A cloud appears white because it scatters all the colors, red, green, and blue, and all those colors get mixed in the cloud, and they make us see white. And then lastly, a sunset, the reason you see a red sun on the sunset is because we have Roy G. Biv, and as the sun is setting during the day, it's just a blue gets scattered. So we knock those out, and we have green, yellow, orange, and red, which add together to center on yellow. But as the sun is setting, more and more of these get knocked out. So if green gets knocked out, we're shifted now toward orange. If yellow gets knocked out, now we're shifted toward red and orange. And if orange gets knocked out, now we're just red. So the sun appears red when it's right on the horizon because everything else has gotten scattered. And if you have lots of pollution in the air, more stuff will be scattered, so the sunset will be prettier. All right, number 2. Which portion of the electromagnetic spectrum is used in televisions? The answer is radio waves. Those are the ones that we use. So number 2 is radio waves. It's just the one we use to get the waves to get the information to the TV through the process known as modulation. Okay. Number 3. What is the wavelength of a microwave that has a frequency of 3 times 10 to the 9th? Well, we're doing V equals lambda F. So we do 3 times 10 to the 8th equals lambda times 3 times 10 to the 9th. So if we do this, we should get 1, let's see, sorry. It should be 1 times 10 to the negative 1 meters, or 0.1 meters equals lambda. Alright? 0.1 meters equals lambda. Alright, which would be B. Number 4. The farther light is from a source, the more spread out light becomes, and so the answer should be, number 4, the answer should be A. So what happens is, if we have a flashlight, pretend this is a flashlight. I know it's hard. Definitely the flashlight. Alright? And so you should note that if we put a barrier here and we shine this flashlight, you would see a circle from like here to here, because the light would come out and it would cover that area. But if we instead, we have a flashlight again. Alright, and now we're going to put up a barrier way back here. Well, the flashlight will now cover a wider range, and so we'll see light from here to here. Okay, so the farther you get away, the more light spreads out. Number 5. When a straight line is drawn perpendicular to a flat mirror, at the point where an incoming ray strikes the mirror surface, the angle of incidence and the angle of reflection are measured from the normal, and they are equal to each other. So A. Number 5, the answer should be A. It's the same on all of these. So if you have, this is the mirror, if you have a ray coming in and a ray going out, and the normal is perpendicular, a line perpendicular to the surface of the mirror, this angle should be equal to this angle. Alright, they should be equal to each other. Number 6, when 2 parallel mirrors are placed so that their reflective sides face one another, blank images form. This is because the image in one mirror becomes the blank for the other mirror. The answer is multiple, because the image in one becomes the object for the other. So you should have multiple images form, and this is very similar to what happens whenever we have a everybody's done this at one point, right? If you're a kid, you have like the tri-mirror in the changing rooms, right? And then you stand like in the middle of it, and you see like all your reflections. Like this one, you start seeing reflections here, and then you see one here, and then you see one here. And that's because this mirror, the object that's in this mirror, is the image in the mirror here becomes the object for this mirror here, and then vice versa. So they just go back and forth, back and forth, back and forth, and then you end up seeing it looks like on to infinity. Alright, so the answer 6 should be A. Number 7. Which of the following best describes the image produced by a flat mirror? Well, a flat mirror, here's a mirror. Remember that if you draw an arrow, okay, the place where that arrow is, let's just call that the height of that arrow, it should be the same on both of these, right? So you should see, bam, angle of incidence equals angle of reflection. That's 0 degrees, so it bounces straight back out. Trace that back. Angle of incidence should equal the angle of reflection, so that does like this. And that means that we have our thing right here. Now, if I'm a good drawer, I'm not, obviously, because this is not exact, but this distance should be the same, and this height should be the same as this height. Okay? So the answer to number 7 is the image should come up, magnification of 1, alright? So it should be magnification equal to 1. It should be upright, and it should be virtual. Again, it's virtual because these lines are dotted. The image forms behind the mirror. If the image forms behind the mirror, it is a virtual image. So the answer should have been C.